My name is Kasper, and this is Dagobert. This is Chaos Beat and Borbug. And we started something called HALIC. And it's about live coding visuals and live coding music. And HALIC stands for, well, let me quickly go through that. Whoops. So it stands for Heuristic Algorithmic Interactive Computing. And to me it was striking that there's some resemblance to DevOps coding, as we're actually coding the program while making the music or while making the sounds. And that's why, well, we started this thing, and then you could call it a search for musical and graphical synesthesia. Using computer technology. So, just a small bit of background. I'm going to go through this really quickly. This is us live coding, and more importantly, this is the human part of HALIC. So H stands for humans, and also heuristics, but it's a collaboration between computers and people, actually. My background is I work at the Media Innovation Center, the iMinds Media Innovation Center, and I did lots of things before that. For example, I crashed my computer again. No, yeah. I did some stuff with analog tools like pen and paper, and then it got digitized. I was 8 years old. I was really excited about this. And as I moved along in all this, maybe I should skip all this, but yeah. So yeah, analog tools and analog output is the same principle, but then everything's analog. One of the next things I did was, because I'm an architect, and I started making pieces of art for an artist, and this is 11,000 hand-drawn, well, pieces on a computer, and it's quite an elaborate work. And at some point I thought, yeah, maybe there's some way to automate this. And automating things is a good thing with computers. It's really easy if you can fit it. But I'll come back to that. First, I'll give the mic to my colleague here.
Hello. I'm going to make a more approach like a musician. This is me playing my self-made electronic drums. It's really easier than it seems. It's just using piezos. And this picture you see is like the computers they used to use in my neighborhood. I didn't own one because they were too expensive. It's like the Atari Mega STN. That's too fast. Well, I don't know if you all know those machines anymore. It's a long time ago. But they were actually very good in making music. Just you could record in some programs like Cubase, put some notes in it, and it would reproduce them. And you could make your own arrangements. It was very interesting. But like being a drummer, and I come from a little city up north, I was interested in using computers in a different kind of way. And that's the next slide. This was more interactive kind of approach. It's an old program from Cycling 74, a long time before Max was developed. And you could play some notes in it, but the computer would organize and reorganize it in the way you put the parameters in a certain structure. But then next thing came. Also, first it was on Atari, before it was on Macintosh, like Symbolic Composer. It's a program written in Common Lisp, and it got more and more interactive because you can write your own algorithms, and that's why I got interested in coding. That's my approach to making music. You could make a whole sequence in like 5 minutes. Normally, if you would rearrange these kind of things in Cubase, it would take like 3 days. So it was very interesting to see this thing happen. Well, what's the next one? Okay, back to Kasper.
Yeah, well, the next one is a supercomputer, and if you want to make music with humans and computers, then you also need a computer. This one particular computer, it's a supercomputer, and it's Deep Blue. It's a computer that beat Kasparov in playing chess. So this is him, the poor guy. He lost from a computer, and he said, well, it's a pity I lost from this thing that is nothing more than a fancy alarm clock, because actually Deep Blue was only crunching 2 million moves a second instead of getting really insight in the game of chess. Like I suppose we can admit that Kasparov is probably better at. So the thing is, just heuristics and algorithms is not good enough. It gets you in a conflict story. It gets you in a computer versus human story. And Deep Blue is not an instrument. It's a tool, and that's exactly what live coding is trying to make better. So the computer should become an interactive tool and more an instrument than just a thing to crunch numbers. Yeah, I'll come back to some more comparisons, but actually the first live coding tool, in my opinion, was the Moog modular. It was both an instrument and it was a tool which engineers used to create sounds. And then, well, time passed by, let's say, and these computers became more and more interactive, and live coding tools were coming along, like this one, Pure Data, which actually is the Moog modular transposed to software, and it allows you to be interactive with the computer. It's in a running program. You can change patches and wires, but it's still very difficult to, say, create 1,000 oscillators at once, or turn 3 knobs when you only have 2 hands, or 1 mouse. Well, back in the days when we only had 1 mouse connected to the computer. So the next thing is, the next natural step is code.
Well, after being twisting around with a symbolic composer, there was something was lacking for me. It's like the real-time issue. Like if you want to jam with some musicians and you want to use code, symbolic composer didn't supply what I needed. And then suddenly this thing goes on called live coding. So 5 years ago I met Alex Mclean, a really nice guy and a very good coder. And he was one of the guys developing this new thing called live coding. And this is what you see here. Is actually we both use Clojure as a language. Other guys use Xlang or Haskell or make their own environment. I use Overtone. It's made by Sam Aaron. It's like a library for Clojure. And maybe we now go to some examples. Yeah. So we have to switch monitor for a second.
Well, maybe you start making music, and before we switch monitors, I'll quickly go through some more examples. So for me, this interface, because up until now I've been just uncommenting code and running it as part of the slides. But this is really a prototyping tool to quickly create sketches with one hand, in this case. So if you would say I draw a line, that's not really, say, a hard example, of course. But the thing is, there's an interface on all this text, and yeah, it's interesting to use. Yeah. just do it with one hand and it's certainly going to crash, right? Oh, that was fun. I'll just keep the real life coding for the festival tomorrow and get to the experts here. But just one more thing about the live coding is that you can. It's compiling the code on the fly and injecting it in a running virtual machine. And for me, that's something really cool, and it enables you to be really close with the machine and the computer and the code, and get really close to all the possibilities of the computer. And that's why we started the live coding, I think. But tomorrow I'll be doing visuals together with Dagobert, and we also have Alexandra Cardenas and Rennick Bell here, who are from Japan and Colombia, and they will also give a showcase tonight. So I'm gonna stop talking here.
So I'll give you a brief introduction what I'm using here. Ook wel luider. Oké. Ja, ik zal er wat terug doen. Hè. Voilà. This is an example for synthesizer technique I'm using here. It's like subjective synthesis is comparable with what you would use in an analog synthesizer, actually. So we have some oscillators here. Could you mind, sir? I'm trying to talk here. You're kind of loud. What you see here is like two oscillators. Ah, this is convenient. This we should use before. So here I'm swapping some live paths who are defined downstairs. I'm used to scramble my code like not in the usual way. It's for my convenience. Sometimes it's easier to get things close, and so that's not the normal way, I guess. So what you see here, the chords are coming from sort kind of pattern things I use, and the sounds are all for the strings. I'm using FM synthesis. For people into synthesizers, might be interesting. I'll give you a clear example. So I'm gonna slow down the kick with a different pattern. I'm not gonna write them right now because of lack of time. So now we're going into this pattern for the bass drum, like the kick here. I'm gonna stop the chords, like a pattern with a 0. Well, the chords will stop. We still have the bass drum running. And now I'm gonna use some tones and show you that I can adjust the synthesis within this FM synthesizer, where I'm not going to go too complex in synthesis of sound, but it's like one oscillator is going to influence the other one. So I use a sine oscillator here, and this one is a sine oscillator. I'm going to use different kind of data to modulate the first oscillator. So this is the one I'm going to use. I'm going to put in a sine oscillator to get you the clear example. Oh, it's not in Belgisch. I have to switch this to Dvorak. Voilà. I'm going to evaluate, and now I'm going to put in some tones. For instance, just one tone to make it clear. I'm going to use A. But just one tone. It's playing 16ths, like you can see in the pattern. stop this to make the example clear. Well, now I'm going to change this. Like, for instance, a fractal approach. Okay, same note, just one note. And you can hear a lot of different notes in there. Oh yeah, okay, it's not clear enough. Thank you, Renick, thank you. So now you hear one note, but you hear a lot of notes. That's because this one, the Lorentz, is triggering and modulating the first oscillator. I'll give you another example. We're going to use Hasher. First I'm going to use a zero pattern. Again, just one note. And you hear that it modulates. I'm going to make it work. Now I'm going to play 8 notes. Or even, to make it clear, 4 notes. Voila. Okay, some different patterns now. Okay, now I'm going to build a short example of a sequence that I can use for algorithm approach. Put in some hi-hats. And this is actually the opposite sequence I'm going to use for the hi-hats. Now it's like 2/16 and 8, and I'm going to use now 8 2/16, so the opposite. Voilà. Put in some snare. On well, maybe to make it clearer, first on the 2 and the 4th part of the bar. Voilà. Now I'm going to start talking and just make a little track. now like to invite, we have two coders here tonight, like Rennick Bell, and would like to introduce him straight from Tokyo. Maybe you can use this stand for the audio.
Oh, there we go. Okay, let's see. Yeah, just say, I got it. I just have to connect, sorry. Oh, yeah, that'd be cool. I should get X-Randar. Let's see. 1024. Why is that? It's like flickering off and on. Yeah. Let's start this way. Okay. I've got one in my bag if this one is also not okay. Yeah, that's cool. Huh? Damn it. Yeah. Hmm? There, yeah. Great. I'm gonna do it like this, okay? Okay. Okay. Yeah. Okay, so sorry. My name is Rennick Bell. I'm a doctoral student at Tama Art University in Tokyo, and I'm researching live coding. And to do live coding, I use, among other things, a Haskell library that I've written called Conductive. Okay? And so I thought I'd just quickly tell you why I'm live coding and then the tools that I'm using to do live coding and what exactly it is that I'm doing when I'm live coding. Okay, so the reason that I'm live coding, I wanted to perform generative music live with the computer as an active partner. And that's because it makes it possible for me to do much more than I'm physically able to do on a traditional instrument. So before I was a guitarist and I'm stuck with just these two hands, and I'm a drummer and I'm just stuck with using two sticks and my feet, and I wanted to do all of that at the same time. So I wanted to be able to do free improvisation like this drummer, Han Benning. But not just Han Benink. I wanted to do Paul Nielsen Love also, and not just these two, but I wanted to be a conductor like Butch Morris, and I wanted to conduct an ensemble of Paul Nielsen Loves and Han Beninks. So that was my intention. And that was my intention, but unfortunately, sometimes I just sound like this, me and directing a whole bunch of robots. But that's my intention behind doing live coding. So what exactly is it that what are the tools that I'm using? So this is what I use. So here I am, and I've got this interface of Vim and, yeah, all right, Vim, and GHCI, the Haskell interpreter. And that looks something like this. Try to get this on the screen so you can see at the same time. Oh, thanks a lot. So on the left side, you can see there's the Haskell interpreter, and over here on the right side, I have the Vim text editor, and I use tmux and a Vim plugin called tslime to send my code from Vim across to the interpreter. And then, of course, this is all going out to the projector on the screen. And to make sound, I've got a library running in GHCI, and this is sending sound to, it's sending OSC messages to a software synthesizer called SuperCollider. SuperCollider also has its own programming language, but I'm not using the programming language, I'm just using the synthesizer component. And I'm sending messages to that synthesizer using a protocol called OSC. And so it triggers my library, and the running code in GHCI is sending messages and triggering a sampler that's built on SuperCollider, and that's processed through some software effects just to make the sound fatter, and then that goes out through jack to the speakers here. So that's the technical setup of what I've got, okay? But like I said earlier, I didn't really want to sound just like this set of robots, so I've written this library to be able to make rhythms more like these guys. And it gets into some complicated stuff. So there's this event loop running, and it's playing rhythm patterns like this, and I can change the density of these patterns, and it gets rather technical here, but it's all about ways to make rhythm patterns, both simple rhythm patterns and complex rhythm patterns, and be able to change them quickly while I'm live coding. And the algorithms behind this, there's a stochastic algorithm, and there is an algorithm based on L systems, which you might have seen used to generate fractals. So I'm using these kind of algorithms to help generate my rhythms and make music. And so the result is that it sounds something like this. So over here, I've already loaded some code, and over here I'm going to set a drum set, and we'll start to play some drums. Okay, so I have one pattern going, and like I showed you here, I'm able to control the density of these rhythms. So I have a function here, and if I hit enter, it executes it, and you can hear a change in the sound. And I can make that change follow an envelope. And then because it's a sampler, I've loaded the sampler with about, at the moment, about 3,000 different audio samples, and I can change those samples at any time. So if I execute this function, you get a different drum set. And of course, we get tired of this. We get tired of this drum pattern if it were playing the whole time. So I've generated a few thousand different rhythm patterns and loaded them, so we can start to sample the different generated patterns. And of course, we don't have to stick with just drums. We can add some other sounds as well. And one of the fun things about live coding is sometimes you get errors, and you show your errors to everybody. So let's try to fix these errors. Again. And so, using this kind of manipulation of code, we can create music. Okay? Thanks a lot. So please come tomorrow night and hear us develop this stuff into a real performance, okay? Yeah, no problem.
Would now like to introduce our second guest from Colombia, Alexandra Cardenas.
Hello. Thank you. Let's see. I'm a composer, so I want to give you my point of view, the point of view from a musician who approaches code and programming. I was trained as a classical composer, so yes, I would like to, okay. So I was trained for writing for orchestra and ensembles, but then I discovered electronics in classical music. So the electroacoustic music started after the Second World War, and so composers were creating music with tapes and with analog synthesizers. But then the computers appeared, and then we had the possibility to make these electronics in live, making a performance with other with the instruments. Yes. So wait a second. Okay. So I don't know. I'm nervous. Sorry. Which resolution would be better? I'm gonna try. Just try randomly. Okay, this looks okay. So I started working with Max MSP in the 90s when I was 15 or so, and discovered the potential of of the computer and started slowly understanding that the computer is a new musical instrument. Now people ask me, what do you do? What instrument do you play? And I say I play laptop. Yes, so this is quite new. And still some composers are quite disgusted by the idea, but there's nothing we can do. Here, this is a new musical instrument. So live electronics changed the face of the classical music, and the computers are to blame, because now we have here such an amazing range of possibilities, synthesizers, sequencers, everything we can imagine, and it also brought the erasing of borders. So now a composer can be someone who studied architecture, or an interpreter can be a composer. So all these ideas, this interaction between machine and human has established a new ideas, yes, new questions. So what is a composer? Only one who was training 15 years at the conservatory, or maybe a philosopher who really codes very well and can make really great music? So this also has been very important for classical academic music, the coming of generative music. So I mainly work with, as you can see here, for instance, this was in Tokyo 2 years ago. I wrote for koto and flute and was processing the sound with Super Collider. I also do live coding sessions, as I hope you have now an idea what live coding is writing the instrument and playing the instrument in front of the audience. I also play my guitar and transform the sound with the computer. And I also do algo raves. Well, not a lot. I'm just starting with the algo raves. But what I do is, always with my background of electroacoustic musician, making my electroacoustic pieces abstract in the tradition of the European music. But this is another border that is being erased thanks to the live coding practice. We are now making dance music, for instance. So I want to tell you briefly how I started. I was living in Mexico City, and this is like the Ministry of Culture in Mexico. They were giving free lessons on coding, how to program in different softwares. Here, we have the Multimedia Center, who organized every month a live coding session. And this was completely for free. And thanks to this initiative from the government, Mexico now is one of the most biggest scenes in live coding in the world. Really, a lot of young people are very interested in live coding now in Mexico. I want to show you just a little video of the first live coding symposium in Mexico. But I don't have sound. This is Alex Mclean. We will see him tomorrow. And this was the one of the first algo raves in Mexico. Okay, this is quite a long video, but I wanted to show you that in Mexico, how is it going with live coding in Latin America? Mexico is leading. Also, other countries in Latin America are going very well and very interested in this. And recently, I've been invited to India to teach in a couple of universities. They have in Chennai, the south of India, this festival called Kurukshetra, which is the battle of the brains. And yeah, I was there to teach what live coding is. And I think it is very important to keep this in mind, that a lot of young people from these countries are so interested and so brilliant and so well educated in computer science. So I was teaching to programmers, computer scientists, and they were, maybe because both in Mexico and in India we have a very big traditional musical background. It was very easy for them to grasp the musical concepts. And they were making like at the second day they were starting making their traditional melodies, translating them to the computer. That was very interesting to see. Yeah, this is I was 2 weeks ago in this campus. This is actually in the middle of the jungle, but it's a very fantastic campus. The students were around 20, 23 years old. And so I had a room with 100 students, 50 women, 50 men, and everybody was grasping the concepts of Super Collider very, very quickly. Super Collider is the software I use mainly for my music. My friends just mentioned it a little bit. So it's a programming environment where I program my music. And you will see tomorrow what I do with it in the Algo Rave. I mix my academic music with a little beats. Okay, so yeah, and I also wanted to show you the page of Top Lab, if you're interested in researching a little bit more about live coding. This is a place where the main references of what's going on in live coding, and a lot of, even the manifesto and a lot of music videos. Yeah, I think that's all.